In the next part, we are going to discuss a couple of statistics that describe the shape of distribution. Actually, they can describe shape of any distribution, but we will talk mostly about the normal distribution in this case. And these statistics are skewness and kurtosis. Well, you already know that mean and standard deviation also actually can describe the shape. Mean tells you where the center of the shape is, and the standard deviation tells you something about the spread. And now we are going to learn these two new statistics. Both are properties of PDF shape, so they describe the density distribution shape, and skewness describes how symmetric distribution is. So it means that if you think about center, how the left part similar to the right part, okay? Then kurtosis tells you something about narrowness or peakedness of the distribution. It means that if you think about the biggest density part, how narrow this biggest density part is, okay? So let me give a couple of examples. So that's the formula for skewness. It looks, of course, scary. We have a lot of different mathematical operations, but look at this part. So this is the simplified version. This letter E is called expected value. So you can think about average, okay? If you look at what is here, what is located here, x minus average divided the standard deviation. So it's like a z-score, and then you take in a power of 3. So it's a z-score in a power of 3, and then it's expected value. So it's like average. If you take z-scores, to take a power of 3 for each, and then calculate the average. Now let's think a little. Z-score is negative. Z-score is negative if the value is below average, right? And then z-score is positive if the value is above average. And then if a value is equal to average, the z-score is equal to 0, right? So if you have symmetrical distribution, then the number of negative z-scores and positive z-scores will be about the same. If you take any negative number to a power of 3, you will have also negative number, just a bigger one. And the same about positive. You take a positive number in the power of 3, you will get a positive number, just a bigger one. Then if you average them, of course, in the case of symmetrical distribution, the average will be 0 because you have the same amount of negative and positive values. But if you have some extreme negative values, the average value will be negative. If you have some extreme positive values, so it means that the z-scores for the positive part will be larger than the z-scores for the negative part, then you will have the positive value, right? So and that's exactly what skewness is. So skewness can be negative, positive, or equal to 0. It's equal to 0 if you have a symmetrical, ideally symmetrical distribution. It's negative if you have some extremely small parts, so z-score is negative. It means that you have some x values that are far from the average to the left. So it means that they are smaller than the average. And then the skewness is positive if you have some extremely large values. So the x values, some x values that are much larger than the average. Okay, let me show you some illustration here. First of all, this is how to do it in R. I'm not going to talk about this right now. We will have another video on how to do all these things in R. So this is an illustration. So let's start the blue one. So you can see that if we hide this part, then the distribution looks almost symmetric, right? So that's how it should be if it's symmetric, okay? But because this is the average, okay? But because we have this, it's called heavy tail, so it means that the right tail is larger than the left tail. So you have some extremely large values on the right, okay? So you have some extremely large values on the right, they are larger than mu, and therefore the skewness will be positive in this case. Or we can call it a right skewed distribution, so it means that you have some problems, so to speak, on the right tail. So you have some extremely large values on the right tail. Yeah, it's a small amount of values. You can see the density is small, but still they change the balance between the small values and the large values. Now, if you look at the red curve, so you can see the opposite. Again, the distribution can be symmetric if it looks like this. So this is the average, but now we have this heavy left tail. So you have some extremely small values, extremely, of course, comparing to this one, to this interval, right? So we have some interval, heavy tail on the left, some extremely small values, which again change the balance, and now the skewness will be negative. So, or we can call it a left skew because we have a sort of problems on the left part. So that's the skewness. On this slide, you can see how skewness changed this balance, okay? So I used 3 statistics here. You already know the average and the median. And then there is one more statistic, it's called mode. We will talk about mode a lot when we discuss the qualitative data. In this case, mode, it's just a peak. So you can see I have a histogram here. So it's not the theoretical distribution, it's experimental distribution. Mode is the peak on this histogram that have the largest height, okay? So if you look at this plot, if distribution is symmetric, all 3 statistics will be the same. So if you have ideally symmetric distribution like normal distribution, mean, median, and mode will be the same, okay? But if you have skewed distribution, it changes the balance between the 3 statistics, and that's how it works now. So you can see that if you have a right skew, so you have a heavy tail, you can see that it's not that bad, but still we have some heavy tail on the right, okay? So you can see that the mean is getting attracted by this heavy tail. So mean is very sensitive to this kind of outliers. So they sort of pull the mean in this direction. Then you have median here, and then you have mode here, okay? If you look at the left skewed distribution, so when we have a heavy tail on the left, it's the opposite. So again, this heavy tail, this extremely, in this case, small samples, they sort of pull the average and the other statistics to the left now. And then you can see that indeed you don't have all statistics the same, okay? If you talk about, for example, the ratio between the values smaller than average and values larger than average, then if the distribution is symmetric like it's shown here, then the ratio will be 50-50 always. So for symmetric distribution, the mean and the median are the same. So mean will play the same role as median. It will split all the values to 50-50%. But if you have a skewed distribution, in this case we have left skew. So this is wrong. It's left skewness. So if you calculate how many values you have on the left and the right part of the median of the mean, you can see that you have only 43% on the left and 57% on the right. So because this heavy tail, it pulls the average to the left, and therefore the average and median are not the same anymore. And okay. So the second statistics is kurtosis. It's a measure of narrowness of the distribution. So how narrow the peak is, okay? So again, I will skip the formula in this case. I will just show a couple of examples here. So you can see again 2 curves. For the normal distribution, if your peak is as narrow as normal distribution, that's the value for the kurtosis. So it should be equal to 3. But if you have, for example, a more narrow distribution, in this case it's a blue curve. So you can see a very narrow peak. So in this case, it will be larger, the kurtosis will be larger, so it's more narrow. If kurtosis is larger, it means that the peakedness, this narrowness, is larger. And then, for example, for the red curve, you can see that it's more flat, it's not that narrow, the peak is not that clear. Then the kurtosis will be negative. So it means that it is smaller than the narrowness of the normal distribution. Okay. So these 4 statistics, average, variance, skewness, and kurtosis, describe the shape of a distribution. So these 4 statistics, average, variance, and skewness, and kurtosis, they describe a shape of distribution of density. And they also, in statistics, they called moments. So you have the first moment, which is a center of the points, and then you have the second moment, which is a width or spread. Then you have third moment, it's a symmetry, and the fourth moment, it's a narrowness. So these are statistics that describe the shape of your distribution.